Today our topic is weighted residual method with two parameters. In previous video we discussed about only one parameters, which is A1. Today we discussed the problem about two parameters, which are A1 and A2. First, how do I identify the two parameters the problem has? Yes, I can explain with this problem. The problem is the differential equation of a physical phenomenon is given by with the differential equation as like d square y by dx square plus 500 x square is equal to 0 with limits of 0 less than or equal to x less than or equal to 1 by using the trial function. The trial function is, the problem has its own trial function, so the trial function is y equal to a1 into x minus x cube plus a2 into x minus x power 5. Here you see in the problem there are two parameters which are a1 and a2. So this problem is used to identify two parameter values. So calculate the value of the parameters a1 and a2 by the following methods. The different methods we discussed in previous problem. Here also we can discuss the different methods, which are point collocation method, subdomain collocation method, least squares method, and Galerkin method. The problem has its own boundary conditions, which are y of 0 is equal to 0 and y of 1 is equal to 0. Here you see both the boundary conditions are same. Okay, so now we can move to solution area. How do I make the solution? Yes. First step, we have to check the boundary conditions level. Where do I check? Yes, from the trial function. Here the problem gave the trial function, which is y equal to x minus x cube, a1 into x minus x cube plus a2 into x minus x power 5. The first boundary condition, which is y of 0 is equal to 0. This boundary condition can be written as like x equal to 0 and y equal to 0. For this boundary condition, if I substitute the corresponding values in the trial function, means y is equal to a1 into x, here is 0 minus 0 cube plus a2 into 0 minus 0 power 5. So all the terms becomes 0. So y equal to 0. So the first condition is satisfied. The second condition is y of 1 is equal to 0. Here x equal to 1 and y equal to 0. Here what happens? Y is equal to, in trial function I substitute 1 where the terms are x. Okay, so a1 into x, for the x I replace 1 minus 1 cube plus a2 into the x 1 minus 1 power 5. If I make the solution for this, means 1 minus 1 in 0, so a1 into 0 0, a2 into 0, which is 0, so that here the second boundary condition is also satisfied the trial function. Here also x equal to 1 and y equal to 0 happens with this solution. So both the boundary conditions are satisfied, which is the first step in our problem. What is the second step? Yes, we have to identify the residual from the trial function. Here the trial function is y equal to a1 into x minus x cube plus a2 into x minus x power 5. Here how do I make the residual with this trial function? According to our problem, in problem d square y by dx square it has. So I have to identify the d square y by dx square of the corresponding trial function. So that first I do dy by dx. What happens? Dy by dx is equal to a1, the x term. If I differentiate the x with the dx, means which becomes 1 minus x cube. What happens? X power n is equal to n into x power n minus 1, which is the formula. Here the x cube can be written as like 3 into x power 3 minus 1, which becomes 2, plus a2 into x differentiated with dx, means we can get 1. So 1 minus 5x means here x power n is equal to n into x power n minus 1. So that 5 into x power 5 minus 1, which becomes 4. So which is the dy by dx function. After that, according to our problem, d square y by dx square available. So that further I can move to identify d square y by dx square. So what happens here? The a1 term available. After that 1. If I differentiate with respect to x means I can get 0. So that I won't consider this. So 0 minus what happens? 3 into x square. Again the same formula I utilized. So 2 into 3 into 2 into 3 I can get 6 into x power 2 minus 1, which become x. Okay. So next a plus 2. Here the 1 becomes 0 minus here 5 into x power 4. If I differentiate 5 into x power 4 means which becomes 4 into 5 into x power 4 minus 1. Likewise I got 4 into 5 which becomes 20 into x power 4 minus 1 x cube. Likewise I got. So the d square y by dx square is equal to minus 6a1x plus what happens here? The plus into minus 20x cube, which is the equation I got from d square y by dx squares minus 6a1x minus 20x cube. So next, how do I identify the residual? I substitute this d square y by dx square on the given differential equation. From this I can get the residual. Here you see, substitute d square y by dx square on given equation, which is d square y by dx square plus 500x square. Here I want to substitute the same function so that residual becomes or is equal to what is d square y by dx square? Already I found which is minus 6a1 minus 20a2 x cube. So I substituted here. Okay, d square y by dx square, which is minus 6a1x minus 20a2 x cube. Where I substitute the given problem equation, in that plus 500x square available. So that here plus 500x square I wrote. After that what happens? Yes, the problem has two parameters which are a1 and a2. So I divide the parameters into 2 because I want to identify two parameters. So that I divide the intervals. Where do I conduct the intervals? Already the problem has its own limits, 0 less than or equal to x less than or equal to 1. So the interval is available between 0 to 1. I can split this 0 to 1 into 0 to 1 by 2 and 1 by 2 to 1. Likewise I can segregate or divide. So from this I can split the problem into two domains, domain 1 and domain 2, which means domain 2, domain 1 and domain 2. So I solve the problem for domain 1. Domain 1, the limit is 0 to 1 by 2. Here I consider where do I substitute on the residual function. So the residual r is equal to minus 6a1 into what is the value x. In from 0 to 1 by 2 I can pick any one of the value. In the 1 by 2, 0 to 1 by 2 there are a lot of values available. 1 by 3 is also lying. I consider the different points. The initial point is 0, the final point 1 by 2. In between those points the 1 by 3 I can pick. So that I substitute the 1 by 3 on this x value. So that minus 6a1 into 1 by 3 minus 20a2 into the same values into 1 by 3 power 3 plus 500 into 1 by 3 square. Likewise, I can substitute the values on the residual equations equal to 0. What happens? Here you see minus 6 3 is available, so which can be divided. So here I got 2 minus 2a1. Here what happens? 23 a2. Here 1 by 3 available, so that it may be converted into 3 power 3. 3 power 3, it can be written as 27. So here minus 20, I can pick the common, divided by 27 into a2 plus what happens here? 3 square available, 500 into 3 square, the 3 into 3 is equal to 9. So what happens? 500 divided by 9 is equal to 0. Likewise, I got. After that, I can simplify again, which means minus 2a1 minus 20 by 27. From the calculator, I can get minus 741 into a2 plus 500 by 9 is, from the calculator I can identify 55.55 is equal to 0. After that, I can get this term it into right hand side, so that minus 2a1 minus 0.741a2 is equal to minus 55.55. Likewise, I got the equation for the corresponding solution. Here you see the 2 is available. How do I replace the 2? How do I make that equation it into some a1 is separated from the total equation, so I can divide by 2. So a1 minus 0.741 divided by 2 is become 0.3705 e2, and then is equal to 27.775. Minus symbol is available. If I multiply with the minus symbol also, the same thing, minus symbol also means here I got plus a1 plus 0.3705a2 is equal to 27.775. Likewise, I got from the calculator under division. From this, I can get the final equation. After that, I can move to substitute the second domain. What happens with the second domain? The second domain is 1 by 2 to 1. Here what is the value? See, 1 by 2. Another point is also lying between 1 by 2 to 1 by 1. So I can pick randomly any one point which is 2 by 3. The same thing what I had performed with the previous step, the same thing I can do for domain 2 also. R is equal to minus 6a1. I can substitute this 2 by 3 in the residual equation, so that 2 by 3 minus 20a2 into 2 by 3 power cube plus 500 into 2 by 3 square is equal to 0. From this, what happens here? 2 by 3 available, so 3 3 2. After that, 2 into 2 4, so that which means minus 4a1, then minus 20a2. Here also 3 cross 3 cross 3, which means 27. So here I got 2 by 3, 2 cube is equal to 8. 2 cube is equal to 8, 3 cube is equal to 27. So here I can get minus 20a2 into 8 by 27. After that, plus 500. What happens? 2 square 4, 3 square 9. 4 divided by 9, this is equal to 0. I can simplify the equation again it into simple form, which is minus 4a1. Here 8 by 27 is available. If I simplify furthermore, I can get minus 5.925 into a1 plus 222.22 is equal to 0. Likewise, we can simplify again for the without form. Here you see plus what happens? Minus 4a1 minus 5.92a1 is equal to minus 222.22. So now I can multiply with the minus symbol. From this I can get 4a1 plus 5.92 a2 is equal to 222.22. So from this I can subtract, I can divide the equation by 4. From this I can get a1 plus 1.481 a2. By the utilization of calculator I can easily identify which is 1.481 a2 is equal to 222.22 divided by 4, which is 55.555, which is the equation for domain 2. Now from this, how do I identify the a1 and a2? Here you see, from the domain 1 I can get the first equation, from the domain 2 I can get the second equation. So if I conduct the algebraic function between the equation 1 and 2 means, from this I can get the, what about the first equation, which is a1 plus 0.3705 a2, what I got from the previous step, is equal to 27.775. After that, what about the second equation, a1 plus 1.481 a2 is equal to 55.555. So I want to subtract both the equation. For the reason I can multiply the first equation by minus symbol. From this I can get minus a1 minus 0.3705 a2 is equal to minus 27.775. The next equation I can keep the same, a1 plus 1.481 a2 is equal to 55.555. If I subtract both the things, now I can eliminate the a1 term. But what about the other terms, which is 1.111 a2 is equal to 27.78. So a2 is equal to 25 I got from this algebraic formulation. After that, now I know about only one function, which is a1. What about the a2? From the substitution of a2 value in equation 4 or 5, 1 or 2, here 1 available or 2 available, I can substitute this a2 value into the other equation. I can get the a2 value, a1 value also. Here you see the equation available, a1 plus 1.481 a2 is equal to 55.555 available. If I substitute the 25 value with respect to the place of a2, from this a1 1.481 into 25 is equal to 55.555. From this I can get a1, I simplify, I can get a1 is equal to 18.53. So from the point collocation method I got a1 is equal to 18.53 and a2 is equal to 25. Now I can substitute a1 and a2 values are in our trial function. What is our trial function? Which is y is equal to a1 into x minus x cube plus a2 into x minus x power 5. In that I can substitute the a1 values 18.53 into x minus x cube plus a2 is 25 into x minus x5, which is the solution I got from the point collocation method. So next we can move to second method. Is in the problem has the second, which is subdomain collocation method. So that subdomain collocation method is also to be identified. So subdomain collocation method. Here the general form for subdomain collocation method is 0 to 1 and r into dx. Likewise we can form like, okay, for 0 to 1 r into dx is equal to 0, which is the basic step Okay, here the 0 to 1 available, but we have to have identify the two parameters which are a1 and a2. So here also I split 0 to 1 by 2 and 1 by 2 to 1 according to our problem condition, which is 0 to 1 available. So that I divide that into 0 to 1 by 2 and 1 by 2 to 1. Here for domain 1 I substitute the limits 0 to 1 by 2 or dx is equal to 0. Now in previous step I identified the r value, which is residual minus 6a1x minus 20a2x cube plus 50x square already we found. So we can directly substitute that r into our equation. So I can get 0 to 1 by 2 or minus 6a1x minus 20a2x cube plus 500x square into dx is equal to 0. Now I integrate this trial function equation minus 6a1 into x. What happens if I integrate means 6a1 into x? What happens if I integrate the term x means which may be x power n plus 1 divided by n plus 1. Likewise I can utilize the formula. So here also minus 6a1x I got, so minus 6a1 into here x available according to this formula, x power 1 is available, so that x power 1 plus 1 I got x square divided by 2. The intervals 0 to 1 by 2. Likewise I can move to next step, minus 20 into a2, here x cube. So x cube, x power 3 plus 1, x power 4 divided by 4. The limits are 0 to 1 by 2. And then I can move to next elements, which is 500x square. So which can be written as like plus 500x square can be x power 2 plus 1, which is x power cube by 3. The intervals are 0 to 1 by 2 is equal to 0. If I substitute all the values, 1 by 2 values are the 0 on the equation, if I substitute 0, I can get 0. If I substitute the above function 1 by 2 into the corresponding x means, I can get further. What happens here, you see minus 6a1 into 1 by 2 square by 2. Okay, so I can get this 2 is common term from the equation from outside. So minus 6a1 by 2. Here I have only x square. So here what happens for the x, I can substitute 1 by 2. So 1 by 2 square minus other term is 0. Likewise I consider the second term 20 into a2. What happens, this 4 I can take from outside, so 20 by 4 into a2, 1 by 2 power 4 is available. If I substitute the lower boundary, which is 0, and then the next element is 500. Then I can take the common 3 is outside, so that 3 x cube. What happens, 1 by 2 power 3. If I substitute the upper boundary, substitute the lower boundary is 0. After that I can get the final equation as like minus 6a1 divided by 8. I simplify this 6a1 by 2, 1 by 2 can be 1 by 4, so 2 into 4, which can be written as like 8. After that minus 28 a2 divided by the same thing. What happens, 20a2 divided by here 4, 2 power 4, 2 cross 2 power 4, what happens, 16. So 4 into 16 I got 64. So 20 by a2 is equal to 64. Plus what happens, the 2 cross 2 cross 2, 2 cube is 6. So 500 divided by 3 already available. So the 6 into 3 I got 500 divided by 24 is equal to 0. If I simplify these terms by the utilization of calculator means, I can get minus 0.75 a1 minus 0.3125 a2 plus 20.83 is equal to 0. I multiply all the terms with the minus symbol. From this I can get 0.75a1 plus 0.3125a2, which is equal to, already here the plus 20.13 available. I can move right hand side, means already it means 20.83, so that if I subtract this minus into minus means I can get positive symbol, so that 20.83. After that, in previous step we are having the same equation, 0.75a1 plus 0.3125a2 is equal to 20.83. So the equation can be written as like, if I divide the total terms by 0.75, if I divide 0.75 means I can get a1 plus 0.3125 divided by 0.75, I can get 0.4166a2 is equal to 27.773, which is the next equation, which is 3. After that, for domain 2, I can identify the terms, the same thing for domain 2. The interval is 1 by 2 to 1. From this I can solve the equation. I can get the equation which is I conduct all the same thing with our previous step, but the interval is 1 by 2 to 1, so that I can get from this substitution of domain a1 plus 2.083 a2 is equal to 64.813. Likewise I got from the equation 3 and 4 for further solving. Here you see third equation I pick from previous step, and also I picked the fourth equation from previous step. Here I wrote third and fourth here. How can I simplify? Yes, here the a1 available, here also a1, so in fourth equation also a1 available, both the symbols are positive. So now I convert that negative, so the third equation is multiplied with the 3 minus, so minus a1 minus 0.4166a2 is equal to minus 27.773. The fourth equation I can maintain the same, 2.083a2 is equal to 64.813. Now how can we solve? Yes, I can scratch a1 each other because positive negative symbol. After that, if I simplify 2.083 minus 0.416, I got 1.664 with the aid of calculator. So a2 is equal to, if I minus 64.813 minus 27.773, I got 37.04. So a2 is equal to 37.04 divided by 1.664. From this I can get 22.23. So a2 is equal to 22.23 I got. After that, I can substitute this a2 value in equation 3 or 4 for getting the a1. So I consider the fourth equation for substituting a2 value. So the fourth equation is a1 plus 2.083 into a2 is equal to 64.813. Here I substitute a2 value, so a1 plus 2.083 into 22.23 is equal to 64.813. From this I can get a1 is equal to 18.50. So now I can substitute this a1 value and a2 value on considered trial functions, which is our trial function, which is a1 into x minus x power cube plus a2 into x minus x power 5. I got as like y is equal to a1 is 18.50 into x minus x cube plus a2 22.23 into x minus x power 5, which is the equation I got from subdomain collocation method. Then we can move to the next, which is least squares method. How can we solve the problem with the least squares? The general method is I is equal to 0 to 1, which is our boundary, r square dx, which is the general form available with the least square. The next step, I identify the term variables 2I by 2A1 is equal to 0 to 1 r into dou r by dou A1 for into dx. So then I can move to divide this 0 to 1 interval is into two domains, because I have two variables which are a1 and a2. So now for domain 1 I consider dou I by dou a1 is equal to 0 to 1 by 2 into r dou r by dou a1 into dx. So here what is r? Already we are having the r as like already found. R is equal to, we found, isn't it, minus 6a1 minus 6a1 minus 20 a2 x power cube plus 50 x square. Likewise we found. So I can recall the equation here. So minus 6a1 x minus 20 a2 x cube plus 500 x square. Likewise we can collect the equation from the residual. Now I can perform the dou r by dou a1 for substituting the values in least square method, so that I can differentiate this trial function with respect to a1 from this. We can get 2r by dou a1. The only one term which is a1 has the 6x, other terms are a2, so that all are 0. So minus 6x only available with dou r by dou a1. Next, if I substitute this r value and dou r by dou a1 value it into this domain 1 equation, what happens? Yes, the 0 to 1 by 2 into minus 6a1 x minus 20a2 x cube plus 500 x square into minus 6x to dx. Okay, which is the form, least square form. After that we can move to next step. The next step in least square, dou I by dou a1 is equal to 0 we need. So we can equate this equation it into 0. So 0 to 1 by 2 into minus 6a1x. I collect the terms from the previous. Okay, minus 20a2 x cube plus 500 x square into minus 6x dx is equal to 0. After that what happens? Yes, see here I can integrate the total terms with the x. What happens? Yes, 0 to 1 by 2. Here what about 6a1 into x? Yes, what happens here? 36 into a1 x square I got, plus what happens here? The 20a2 into x cube. So 3 can becomes under x power 3 plus 1 x power 4. So here what happens? All the terms can be multiplied with the 6, so that plus 120 a2 x power 4 minus 300,000 x cube into dx. How do I got? So this a1x minus 20 a2 x cube plus 500 x square minus 6x available. Now I can multiply the minus 6x with each other, so that minus 6x into minus 6, here I got 36 a1 x square. After that plus 20 into 6, here I got, so that's 20 into 6, 120 into x, here x cube into x, I can get x power 4, 120 into x power 4. Here 500 is available, so 6x is available, so that if I multiply 500 x square into 6x means here minus 6 into 500 minus 3000 I got. After that x square into x, x cube into dx is equal to 0. Likewise I can simplify the equation. Again I can move to the integration. Okay, here I can remove the term 36a1 as constant from the equation. After that, the x square available. The general formula is x power n plus 1 divided by n plus 1 integration. So that here 36a1 I removed. For I want to integrate this x square. From this I got x cube by 3. I can substitute the intervals 0 to 1 by 2 here. After that, plus what happens with the second element, which is 120 a2, I can make the constant. After that, here x power 4 available. Here the same equation, x power n plus 1 divided by n plus 1, so that here x power 5 divided by 5. The limits are 0 to 1 by 2. After that, here 3000 available, so that minus 3000 x cubed, the same equation again I placed x power 3. So x power 3 plus 1, x power 4 divided by 4. X power 4 divided by 4. Here also the interval is 0 and 1 by 2. Now I substitute lower limit and upper limit on the equation. I can get the terms, which is 36a1 into 1 by 2. 36a1, I may take the 3 common term as here 3, so 1 by 2 power 3. If I substitute 0 for x, the term is 0, plus 120, the term common term 5, I can move the common term here, so that 120a2 divided by 5, and then x power 5, 1 by 2 power 5. If I substitute 0 for x, here 0, likewise I got. After that, minus 3000, the 4 term I take outside from the boundary conditions. After that, I can get x power 4, here 1 by 2, substitute 1 by 2 power 4 minus 0, likewise I got, which is equal to 0. So here I simplify again, 36 by 3, 12. So the equation may becomes under like 12a1. What happens with the 1 by 2 cube, 1 by 2 cube, 1 cube 1, 2 power cube, 2 into 2, 4 into 2, 8. So here the term is 1 by 8, plus 120 divided by 5. What happens here? The term, which is 24a2. After that, 1 by 2 power 5, 2 into 2 into 2 into 2 into 2. So from this I got 1 divided by 32. Okay. After that, minus here 3000 divided by 4, which is 750, which may comes under like 1 by 16 is equal to 0. Likewise, we can simplify the above equation. Now we can move to next step. If I simplify 12 by a1 into 1 by 8, what happens here? If I substitute here, it may be 1.5. What happens with the 24 and 32, which may becomes as like 0.75. After that, if I simplify this term, which is 16 into 750, which comes under 46.875. With the aid of calculator, I can calculate. So I can recollect this step for further simplification. I can get 1.5 a1, because here you see 1.5 into a1. After that, plus what happens for a2, 0.75 into a2, 0.75 into a2 is equal to here the common term, which is not have any variable, so that we can move this term it into right hand side, which is 46.875. So which is equal to 46.875. Likewise, I can frame the further equation. So a1 plus 0.5 a2 is equal to 31.25. If I divide the total equation 1.5, if I may get this kind of equation. After that, for domain 2, I can perform the same as usual steps, which can be differentiated with the dou a2. In previous, for domain 1, I can differentiate with dou I by dou A1. Here I can differentiate for domain 2 is dou I by dou A2. So dou I by dou A2 is equal to 0 to 1 by 2 or 1 by 2 to 1. The same condition, which is r into dou r by dou A2 into dx. Here the r is equal to, I can pick r is equal to the previous, which is minus 6a1x minus 20a2x cube plus 500 x square from the previous step, so that minus 6a1 x minus 20 a2 x cube plus 500 x square from this 2r by 2a2, which is equal to minus 20 x cube, because the a2 term only available with the second element, so that minus 20 x cube only possible. So substitute the same r and dou r value it into the above equation. We can get 1 by 2 to 1. R value is minus 6a1x minus 20a1x cube plus 500 x square into minus 20x cube dx. This is the formula for the substitution of r and dou by dou a2 value is in equation. So what happens? The requirement, yes, what about our requirement? Dou I by dou A2 is equal to 0, which is our requirement. So we can equate 1 by 2 to 1 minus 6a1 x minus 20a1 x cube plus 500 x square into minus 20 x cube into dx is equal to 0. Likewise, we can simplify. What about the next? Yes, we can again simplify this, minus to multiply the minus 20 into the terms. So 1 by 2 to 1. What is 6 into 20? 120. Already the minus available, so that 120 a1 x power 4 plus 20 into 20, which is 400 a1 x cube here available. Here also one of the x cube. If I multiply x cube power x cube means x power 3 plus 3, which means x power 6 came. So that 400 into a1 into x power 6 minus 500 into 20. Okay, here plus symbol available, minus symbol, so that I can produce here minus. So 500 into 20, which becomes 10,000. What happens? X power x square x cube. Yes, I can multiply x into x, which maybe comes under common. After that, the exponent 2 3 available, so 2 plus 3 is equal to 5, which is equal to 0. After that, I can substitute, integrate the terms. So I can get 120 a1 into here x power 4 available. If x power 4, if I integrate with respect to x, means I can get the terms as like x power 5 divided by 5, because x power n plus 1 divided by n plus 1, so that x power 5 divided by 5, so that here I can represent the equation with the x power 5 divided by 5 with the limits 1 by 2 to 1 plus the next system automatically 400 a1 into x power 6 available, so x power 7 divided by 7, the limits 1 by 2 to 1. Then third element, which is minus 10,000 x power 5, so that 10,000 x power 5, which becomes x power 6 divided by 6. The lower boundary is 1 by 2, upper is 1, which is equal to 0. After simplification of these terms, I can get 23.25 a1 plus 56.695 a2 minus 1640.626 is equal to 0. With the aid of calculator, I can perform those things and I can get this equation. After that, I can move this unless variable without variable having element available, so that I can move this it into right hand side. So 23.25a1 plus 56.695a2 is equal to 1640.626, which is the equation. So now further I move to divide the total equation by 23.25. So I can get a1 plus, if I utilize the calculator, I can get 56.695 divided by 23.25. From this I can get 2.438 a2 is equal to 1640.626 divided by 23.25. From this I can get 70.564. So which is the equation of then in previous I named the equation as like 3 and 4, 3 and 4. So now I can call this equation as 5. Okay, after 5 you can move further simplification of this equation. So I can solving the equation to this here, a1 plus 2.438. In previous I got minus a1 into plus minus 0.5a2 I got in previous step, which is for domain 1. What happens? Yes, for domain 1 equation is for domain 1 equation I got a1 plus 0.5 a2 is equal to, I got the equation which is 31.25 minus 31.25. likewise I got from the domain 1 I have the equation a1 plus 0.5 a2 is equal to 31.25. and what about this domain 2 equation, which is fifth equation, which is a1 plus 2.438 a2 is equal to 70.564. so now I want to eliminate the term. So the first term is multiplied with the negative symbol, so that here minus, here also minus, here also minus I got. If I simplify the terms, the a1 cancelled. After that, which can be identified through calculator, 1.938 a2 is equal to, if I subtract the both things, I can get 39.314. so a2 is equal to 39.314 divided by 1.938, I can get 20.28. likewise I can got. After that, if I substitute this a2 value in equation above, equation 5 or 4, from this we can get the a1 value, which is the domain 1 equation already available, a1 plus 0.5 a2 is equal to 31.25. so for identifying the a2, I can substitute this one, a1 plus 0.5 a2 is equal to 31.25, because I got a2 is equal to 20.28. so here I substitute a2 value, so a1 plus 0.5 into 20.28 is equal to 31.25. here if I simplify the term, I can get a1 plus 10.14 is equal to 31.25. so a1 is equal to 31.25 minus 10.14. from this I can get a1 is equal to 21.11. so the trial function according to the least square method, y is equal to 21.11 into x minus x cube plus, what about the a2, 20.28 into x minus x5. likewise I got the equation from the least square method. After that, Galerkin method. The general form of Galerkin method is general form of Galerkin method is I is equal to integral of 0 to 1. According to this problem, interval is 0 to 1, wi or into dx is equal to 0. Here for domain 1, 1. Here also I can identify the domain 1 and domain 2, so that for domain 1, 0 to 1 by 2 wi or dx is equal to 0. Here what happens with wi in our trial function? There are two functions are available, which is x minus x cube, x minus x5. For domain 1, the trial function is x minus x cube only. So I can pick this as a weighted function, which is x minus x cube as the y. Here y is equal to wi. The first term is x minus x power cube. So which is the weighted function? After that, residual r value already I know. According to this equation, r value already we know. R is equal to minus 6a1x minus 20a2x cube plus 500x square, so that I can substitute the same r value it into the equation. So minus 6a1x minus 20a2x cube plus 500x square. So we can write the equation 0 to 1 by 2 into x minus wi is x minus x cube. After that, the trial function minus 6a1x minus 20a2x cube plus 500x square into dx is equal to 0. Likewise, we can substitute. From this substitution, after solving the problem, we can get the equation for domain 1 is a1 plus 0.4832 a2 is equal to 30.651. Similarly, for domain 2, what is the difference between domain 1 and domain 2? In domain 2, we can consider the intervals 1 by 2 to 1 wi or dx. Here what is w? Yes, r is common, the same 6 minus 6a1 minus 20x5 plus 500x square. What is wi? Y is equal to wi. According to our problem's trial function, the second is x minus xy. Here you see x minus xy, so that I can pick that x wi is equal to x minus x power 5 as the wi value, and r is equal to minus 6a1x minus 20a2x cube plus 500x square. If I substitute both the things with the above differential equation, I can get 1 by 2 to 1 wi is x minus x power 5 into minus 6a1x minus 20a2x cube plus 500x square I got. So what happens? Let's see, into dx is equal to 0, which is our general form. If I simplify all the terms, I got the domain 2 equation as like a1 plus 1.843a2 is equal to 61.035. So we got the equation as like for domain 1 a1 plus 0.4832 a2 is equal to 30.651. For domain 2, I got a1 plus 1.843 a2 is equal to 61.035. From this we can get, I multiply the first term with the minus symbol, so all the terms are minus. From this I can get 1.3598 a2 is equal to 30.384. So from this we can get a2 is equal to 22.34. Likewise, I got, if I substitute this a2 value it into our first domain 1 equation, I can get e1 plus, or otherwise I can substitute the same with the second 1.843 into 22.34 is equal to 61.035. From this I can get a1 is equal to 19.862. So here also our trial function is y is equal to, what about a1? 19.862 into x minus x cube plus what about a2 22.34 into x minus x power 5. Likewise we got. So result, how can I write the result? First one is point collocation method. Second one is subdomain collocation method. Third one is least squares method. Fourth one is collocation method. So from this, how can I write a1? What are all the a1 values I got? What are all the a2 values I got? Likewise, I can write according to our point collocation method. What is a1 and a2? Yes, a1 is equal to 18.53, a2 is equal to 25. I got. So I can write the result. A1 is equal to 18.53, a2 is equal to 25. Similarly, subdomain collocation method. In subdomain collocation method, a1 is equal to a1 is equal to 18.50, a2 is equal to 22.23. So I can write here a1 18.5, 22.23. Similarly, I can pick from the least square method. From the least square method, what is a1 and a2? Yes, a1 is equal to 21.11 and a2 is equal to 20.28. So here I can write 21.11 and 20.28. What about Galerkin's method? Here also I got a1 and a2 value. So a1 is equal to 19.862 and a2 is equal to 22.34. Likewise, you may write your answer on paper or notebook. Thank you. If you are having any doubts, you may ask me through comment box. Thank you all.